Hello students, in this video we're going to learn the basics of how to use the SageMathCell. So if you just go in your search engine and you look up SageMathCell, I don't know if you can see the website, but I'll just type it in for you if you're wondering what the website is for the SageCell. It's sagecell.sagemath.org. So that is the location of this application. All right, so what are some of the things that you can do with SageMathCell? Well, one of the simple things you can do is you could do some plotting. Now, by default, X is the independent variable that SageMathCell is accustomed to. So if you use X, you do not have to declare it. So if we wanted to plot, for example, X squared from in the window X is -3 to 2, then I just close the parentheses. You can click on evaluate, or you could hit Shift Enter. And I should get a parabola on this bottom screen here from -3 to 2. There you go. That's with that command there. Now I can overlay that plot by just using a plus symbol, and for example I could plot let's say the square root of X from X is 0 to 2, and hit Shift Enter, and I get those two there. Now maybe you do not want the square root to be the same color, so I can go in here and I can change the color to, whoops, sorry, kind of fat fingered that, okay, to red, and there you go. Now I have the square root function, looks like red. Perhaps you do not want to see the left axis there, so I can go make that a 0, and I then get something that looks like this, and you can see that these are inverse functions. On top of that, we could plot the line, and let's just plot the line y equals x, x going from 0 to 2, and we'll make that color, we'll make that black. And you can see that the function and its inverse are reflective about the line y equals x. Now, let's say you wanted to put all these plots, you know that they're going to be in the same window, you want them to have a lot of the same features. The other thing you could do here is you could define the variable p1 is equal to this plot here. I'm just going to copy and paste this. And then I'm going to make p2. So you could set up all your plots beforehand once you're clear on what you want all your overlays to be. And if you just hit Shift Enter here, nothing's going to happen. But if I use the command show p1 plus p2 plus p3, there we go. And I get my plot back again. So there's some, this is a basic plotting example that I can show you in SageMathCell. Now, let's say that you wanted to plot something that didn't involve the variable x, and something that maybe involved the variable t or the variable y. Let's say you wanted to plot a slope field. So let me get rid of all this. So to do that, I have to declare the variables y and t. So for example, if I just said, you know, if I put in y plus t, it's going to tell me, you know, look, y is not defined. All right, so it doesn't know what the y is. So I'll use a %. I'll declare my variables. I'll let it know that it's going to be y and t. T and y doesn't matter. And then let's plot a slope field. Now, sometimes you might forget these command names, and you might say, well, it's plot, maybe it's plot slope something. If I hit plot underscore and I hit the tab, it comes up and it gives me some suggestions for autocomplete, and then we say, oh yeah, it was plot slope field. That was it. Now to plot the slope field, I have to do y, and then you might see something like y times y minus 3. if I just do y times y minus 3 as you would write it, you're going to get an error. You need, just like typically like on a calculator, you need to put in a multiplication symbol. Now, before I would have done something like, when I did my basic plot commands in my previous examples, I would have said, oh, I want to go from t is 0 to 5, or t, it's implied that t is my independent variable. I'm thinking of this is a function of y of t. And then, y would go from, let's say, 0 to 5 as well. Now close my parentheses. This is going to cause an error. What you want to do is, because you have the independent variable and the dependent variable, you're going to put those in parentheses like that. Okay? So remember your multiplication, and then remember to put these intervals, the independent variable and dependent variable intervals, into parentheses. Then when I plot the slope field, Shift Enter, boom, there we go. There's my slope field. T was going from 0 to 5, y was going from 0 to 5. Let me shorten the y interval a little bit here. Let's shorten that down to maybe 4 to make that perfectly clear what's going on here. So yeah, you can see the some asymptotic behavior here. At y is equal to 3, it looks like we have an equilibrium solution, and y is 0, we have an equilibrium solution. I can let y go from, let's say, minus 2 to 4. Yeah. Okay. And I can also overlay these plots as well. So I'll call this P, and then I'll make P1 will be a plot of one equilibrium solution, so we'll make that y is 0. And this will go from y is going from minus 2 to 4. And we'll let P2 equal the other equilibrium solution. That would be 3. And this is going from y is 0 to, minus 2 to 4. Oops, I'm sorry. We want this to be t. Sorry. T is going from 0 to 5. The independent variable is t. Y is a function of t. So it's y is 0 from t is 0 to 5. And then y is 3 from t is 0 to 5. So let me put those, let me make that comment here. So this is y of t is equal to 0 from t equals 0 to 5, and then same thing here. This is y of t is equal to 3 from t is equal to 0 to 5. All right, and then let's show p plus p1 plus p2, and there we go. So you could see that the solution here repels away from 3 and it is attracted to 0. All right, so there's some basics of how to use SageMathCell to do some basic plotting for differential equations. All right, good luck.